Hello guys, in today's video we're talking about sets. So what is set? Set is a collection of well-defined objects. Now, and these objects are the elements of the set. The objects are written in small letters, while the set is written in capital letter. Then the set is enclosed with a curly bracket or a braces. So what do I mean? So let's say we have a set of items that we want to buy in the market. So let's call the set A. Set A contains, so this is what I mean by curly bracket or braces. So set A contains meat, rice, beans. So these are the elements of the set, and the set is enclosed with a curly bracket or braces, while the set itself is written in capital letters. So now we'll go into the set notations. So set notations are the ways which represent sets. We have two ways of representing sets. So we have the set notation. The first one we have is called the roster or the listing method. Now from the name, roster or listing method, we just list out the elements of the set, and that's how we represent the set. Just like this one, we listed out the elements of the set. So let's say we have a set of vowel letters in the alphabet, and we call this set V, and it has elements A, E, I, O, and U. So this is listing method. So the second set notation we have is called the set builder form. Now the set builder form is used when the elements of the set have unique property. So what do I mean by this? Let's say we have set of even numbers that even are the unique property of that set, of the elements of that set. So we can represent set of even numbers as a set builder form. So we can say set, let's call this set C. So the way we write it is x for all x. X means the element of the set such that slash, this slash means such that, or this colon or slash means such that x is an even number. So let's take another example. Let's say set V. Like the previous example I gave, set of vowel letters also have unique properties, so they can be written in a set builder form. So you can say x for all x such that x is a vowel letter. So that's how we write set builder form. So the first type of set I'm going to be giving you is called the universal set. So what is universal set? Universal set is a set that contains all the elements of that subject of consideration. So let's we are talking about set of letters in the alphabet. Set of letters of the alphabet is a universal set because it contains all the letters of the alphabet. So universal set can be written in this symbol. This is how this is symbol is for universal set. So let's write set of letters of the alphabet. We can write this using set builder form. X such that for all x such that x is a letter in the alphabet. Now we go to the next type of set, which is called the subset. So a subset is a set that comes out from universal set. So now we mentioned earlier set of letters of the alphabet. We can so a subset are those sets that we can bring out from the universal set. Like we say set of letters of the alphabet. We can bring out vowel letters, we can bring out consonant letters. So all these are subsets. So let's say Let's say set A is vowel letters or consonant letters. Let's say set A is consonant letters. So we say for all x such that x is a consonant letter in the alphabet. We also have a symbol for writing subsets. So when we want to say, if we want to say that A is a subset of the universal set, we use this symbol. So we can say A is a subset of the universal set. So this is how it is written. So the next type of set we have is called the singleton set. So singleton set is a set that has only one element. Let's say set of president of Nigeria. We have only one president of Nigeria, so it's a singleton set because it has only one element. So that's what singleton set is. Now the fourth set is called the null or the empty set. From the name empty set, it doesn't have any elements in it. The empty set is written with this symbol or a braces without any elements in it. So this either this or this is how we write an empty set. So an example of empty set is set of odd numbers that can be divisible by 2 without a remainder. So there is no set of odd numbers that you can divide by 2 and have without having remainder. So the next type of sets we have is called the equal set. Now equal sets are sets that have the same elements without regarding the repetition or the arrangement. So let's say we have set A has elements A, B, C, D, D, and set B has elements A, B, B, D, C, A. So these sets are equal because they have the same elements without we are not regarding their repetition or their arrangement. But if you look, this set A has A, B, C, D. Set B have A, B, C, D. So that is what equal set is. So we have power set as another type of set. Power set is a set that contains all the possible subsets of a particular set. So now what do I mean by this? Okay, let's say we have set A. I said set A contains elements A, C, and D. So for us to get the power set, we have to look for all the possible subsets that we can get from this. So in this case, it's as if we are looking at A as the universal set. So as a set, we can get other set from. So power set can be written as P of A of the elements of the set that we want to find the power of. So we have the first set that we can get from this set is the null set. Always take note, the null set or the empty set is a subset of any set of all sets. So if we want to get the subset of A, null set must be part of the subset of A. So another set we can get is only A, set that contains only A. Another set we can get set that contains only C. Another set we can get is set that contains only D. And A, C, A, D, C, D, A, C, D. This set is a subset of itself. So a possible subset of this set is itself. So you might be wondering why I didn't write CA or DA because the arrangement of a set does not matter. So these are the possible subsets you can get from this set, and that is the power set. Now I'll be showing you a formula that we can use to guess the number of elements of the power set. Now to get the number of elements of the power set, we say P of A is 2 raised to power n. N represents the number of elements of that particular set. That is, let's, for example, A. So the number of elements of A now is 3. So we have PA is equal to 2 raised to power 3. 2 raised to power 3 is 8. So we are going to be having 8 elements for the power set. So let's count the sets here. We have 1, 2, 3, 4, 5, 6, 7, 8. So it's complete. Now we are going to go into the terms that are used in sets. So when we solve set questions, there are some terms that you have to be familiar with when we are solving these questions. So the first one is called intersection of sets. So let's say set A and B contains elements. The intersection of set A and B are the elements that are both in A and in B. So that is the intersection. So let's say we have set A as elements B, D, C, and set B as elements A, E, D, F. So the intersection of these two sets are the elements that are both in A and in B. So which element is both is in A and in B is element D. The intersection of set is written as this. So this symbol is what we use to write. So if we want to say A intersection B, so A intersection B is this. So A intersection B is set D. So that's it. So the second term we use is called union of sets. So union of sets, let's say we have sets. Let me use the same example. We have set A and B. The union of set A and B are those elements that are in A or are in B. That is when we combine the elements that are in A and in B without any repetition. So if we want to find the union of A and B, we are going to combine the elements that are here without repeating a particular element. So A union B is written with this symbol. So we have A union B is equal to A, B, D, E. Now we are not going to repeat the D again. F and C. So this is A union B. Remember, the arrangement does not matter. So another term that we need to know when we are solving set is called the complement of set. So the complement of a set is the set of elements that are not in that set but are in the universal set. So let's say we have universal sets contains elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And set A contains elements 2, 4, 6, 8, 10. Now the complements of set A are those elements that are in the universal set but are not in set A. So we write A complement as A and C, A superscript C, that is A and C on top, or we write it as A and like A prime. So this is, so we have 1, 3, 5, 7, 9. So those are the elements that are in the universal set but are not in set A. So another term that we need to know is the cardinality of set. Now cardinality of set is the number of elements that are in that set. So let's say we have set C contains elements A, 1, 5, D, M. So cardinality of this set is written as n c. That's number of elements of set C. What is the number of elements of set C? We have 1, 2, 3, 4, 5. So you have cardinality of set C is 5. So the system we need to know is called the difference of sets. So the difference, let's say we have set A and B. If we want to find A difference B is the element that is in A but is not in B. So let's say set A contains elements 1, 2, 5, 4, 8, and set B contains elements A, B, 4, 5, 1. So A difference B is written as A slash B or A minus B, which is elements that are in A but are not in B. So which elements are in A but are not in B? One is in A and B, 2 is in A but is not in B, so write 2. 5 is in A and B, 4 is in A and B, 8 is in A but is not in B. So we have 2 and 8. So that's A difference B. A difference B different from B difference A. B difference A is elements that are in B but are not in A. So set so we have B difference A. A is in B but is not in set A. So you have A. B is in set B but it's not in set A. So we have B. 4 is in A and B. 5 is in A and B. 1 is in A and B. So we have A, B. So that is A difference B.